scientist?
I was chief scientist at BP for 5 years after Caltech. And, you know, they didn't bring me there to help them find oil. They knew how to do that really well. I was brought in to help figure out what beyond petroleum really meant. And that was renewables and alternatives. And I helped during my 5 years to help plot a strategy for that, which is today, now, 15 years later, are starting to be realized.
But once you say you work for BP, there's a certain section of our population that will immediately dismiss it.
Yeah, of course, and you know, it's part of a structural problem that the advantage of having been in BP is I learned about the energy system. I teach it at NYU. It's just my first lecture. And so I actually know quite a bit about how the energy system currently works. And a lot of people want to change the energy system have no idea of how it works. And so they can break it down.
Well, in reading your book, one of the things that became very clear is there's so much to sort through. It's incredibly complex. I actually listened to it on audio, and there were sections of it where I had to go back over it again just to try to wrap my head exactly around what was happening, to squash some more of the criticism really clearly up front. You're very clear about this. You believe the climate is changing.
Climate is changing.
I believe that human beings are having an effect.
They are influencing those changes, yes, absolutely. Mostly through greenhouse gases that are accumulating in the atmosphere. Absolutely.
Your position, though, is that there's either an exaggeration or there's a way that people are looking at the data that's alarmist that you don't think is reflected by the actual numbers themselves.
That's correct. I think, you know, in a British sense, they have over-egged the customer.
Now, why do you think this has happened?
You know, I have in the book one of my favorite quotes from H.L. Mencken, is the purpose of practical politics is to keep people along by a series of mostly imaginary problems so that they can be clever to safety.
Now, if you think that human beings are affecting the climate and you think the climate is changing, what percentage of an effect are human influences?
Yeah, so, you know, I think we don't really know that. The UN Intergovernmental Panel on Climate Change in its latest report in August said it's all human caused in the last many decades. All of it. But, you know, they completely forget that the climate was changing comparable ways well before human influences became. And so they say, no, we're doing that, we're going to suppress it. They say it's all.
Now, one of the things you highlight in your book is that when you're looking at the way the temperatures have risen on Earth over a period of, say, like 100 years, that if you do it in these blocks of time, that there's a way to look at it in a deceptive way that makes it seem in the alarmist way, where it makes it seem like radical drastic change is happening over a very short period of time. That's all I've ever heard.
Yeah, so, you know, the climate changes a lot on its own. Maybe we can put up a picture, which is one of the ones I wanted to show you. We put up the second chart in that file called Kuhn Films. And what I'm going to show you is a record of the height of the Nile River, which has been compiled by the Egyptians. Go to that. So this is the height of the Nile River from 640 AD up until 1450. So about 800 years of data every year about what was the lowest level that the Nile River reached. The Nile was important to the Egyptians, as you can imagine, and so they measured it very carefully. And what you see are two things. The blue spikes are the annual values. They go up and down a lot. 1 year it was up 6 meters, 20 feet, and then the next year it was down 1 meter. So a lot of variability. But then then if you look at the curve, which is the average trend of 30 years, you can see, for example, in the first 100 years, it was going down. And you can imagine some medieval Egyptian climate panel saying, new normal, we've got to do prayers and sacrifices. And of course, if they just waited another 100 years, it came back. This was all before humans had any influence.
Are we looking at climate, we're looking at these periods of time, are we looking at them incorrectly because we have such a short lifespan ourselves that we tend to think of great change as happening in these incremental ups and downs, but realistically we should be looking at it on a broad, long spectrum of hundreds and thousands of years.
So climate changes on all time scales. It changes on 1,000-year time scales. It changes on 10,000-year time scales. And it changes on decades. Every decade it changes. And, you know, we also forget in the Midwest, there was a drought in 1955, and one of the news magazines, Time magazine, said this drought will be long remembered. It was 1955 drought. So we forget, and we think things are unprecedented, when in fact they have happened.
Now, you are, by training, you're a physicist, correct?
Correct.
And another criticism would be that you're not a climate scientist. People say that. Now, my question, though, and I think you'd probably be able to help me on this, is like, what exactly is a climate scientist? Because most science, you have a hypothesis, you run tests, you get results, and then you do these experiments, and that's how you get your data. With climate science, is it based off models?
You know, climate science is a very integrative discipline. It involves physics, chemistry, biology, geology, statistics, computer modeling, and so on. So nobody can be an expert. Many prominent climate scientists are trained as physicists. Look at Jim Hansen, Michael Vantage, who was appointed in my graduate school, decided to create a list of and so some of it is certainly physics. I have published in physics about climate science. I published a paper in August where we were watching the moon for 20 years to work out shiny it was. That's very important because it's shiny. So it's more sunlight. We published a paper and it attracted some attention. So I have published books. But more importantly, the kind of things that I've worked out in the book are obvious to anybody who has any quantitative sense at all. It's like, you know, if I were ordering carpet for a room, and the room was 8 by 10, that would be 80 square feet of carpet. If the carpet guy comes back and says you need 400 square feet, I'm going to ask him some hard questions. And that's the kind of misleading things that I'm doing.
How did you get started on this journey of being, I want to say obsessed, but if not fascinated with the science of climate change and the data itself?
So I was exposed to climate science in the early 90s when I was working with a group called JASON for the government, looking at the impact of then high-performance computing and small satellites on climate science.
And the group JASON is top scientists in their field that are recruited to work for the U.S. government. And it's like, what is it, 70% of it is classified projects?
Something like that. We work for all government agencies, but a lot of work we do is for the national security parts of the government.
And it's tackling the most complex
difficult
scientific
technical problems, sometimes mysteries that the government finds going on in other countries. So that's what's going on. So how do we do X, Y, or Z technically?
And so what was the initial study that you read, or what?
So the initial thing that got me interested was the Department of Energy wanted to deploy a fleet of small satellites which, remember, this was 30 years ago, so that was a pretty bad deal, to look at the Earth and monitor what was going on for climate purposes for science. And one of the things that you could do was to measure how shiny the Earth was, the albedo, like this. And of course, being curious, we asked the question, how was the albedo first measured? And the answer was, back in the 30s, something started watching the dark part of the moon. And that brightness of the dark part of the moon is lit by light that's reflected from the Earth. So it's a good measure of how shiny it is. It hadn't been done for the 30 or 40 years, and so we started a program that continues to this day to watch the dark part, to monitor how high the Earth is. And we just published a paper in August that showed the Earth is not not surprising, but it's not. Well, anyway, that sort of got me interested in climate science. When I moved into the private sector, I was more concerned with energy technologies and how we could develop and deploy and demonstrate and deploy technologies that would improve the science. And I did that for a while, the idea that would come up. And then in 2014, the American Physical Society asked me to they had put out a statement in 2007 that was very controversial because it used the word incontrovertible. For physicists, that's fighting words. Okay? So they asked me, Steve recommended your statement. And so I said, heck, we're physicists. We're not going to take anybody's word for it. Let's look at the issue ourselves. So I convened a one-day meeting with 3 mainstream climate scientists and 3 credentialed skeptical scientists. And we sat for a day. Presentations, for discussion in early 2014. It's all up on the web. It was transcribed. It was transcribed. And I came away from that thinking this science is not anywhere near as sound as I thought it was. Because of the problems with the models, the observation, and my little group wound up proposing a statement that could not get through the bigger committee. People would say things like, we can't say that even if it's true because it gives ammunition to the deniers.
How frustrated as a scientist?
Well, I got so frustrated because I'm used to Jason and others of giving advice to decision makers. You play it straight. You say this could be, this may not be. Here are the options and so on. But you don't try to spin the advice to give them. And I was really annoyed with it. I wound up designing for the people, but I wound up then publishing an op-ed in the Wall Street Journal. They gave me 2,000 words, which was great. We had a couple thousand online comments. Many people said, thanks for writing this. Trying to expose the real science of a person established tragedy. Even though I'm just repeating what's actually in the written question.
Now, what was the nature of the criticism?
Cherry, and we get it to this day with the book, cherry pick misleading, what you said is actually not true, and so on, even though I point them, chapter and verse points where these things are said.
So is this, the scientists that are claiming you're cherry picking, are they signaling to the other people that follow the ideology that they're not to question climate change, and that anything that you say that in any way calls doubt to the settling of the data gives some sort of ammunition to people who are the real climate deniers, who are a real problem?
Yes, indeed. And look, my sense is that this is a problem. It's not an existential threat by any means, and it's a problem that we have time to deal with, and we should deal with it in time and gracefully. But I think, when the book first came out, there appeared an article in Scientific American written by, I think, 13 mainstream climate scientists. That was a couple thousand words, mostly ad hominem criticisms, a couple of substantial criticisms which I have regarded as quite effective. But it put a marker in the ground that people who didn't want to have the book understood could point to and say, aha, those guys said could to me.
Now, what criticisms made sense that you could rebut?
Well, they said, for example, I said sea level rise was not accelerating. And of course, I got a whole chapter that talks about the ups and downs of sea level rise. But they would criticize a review of what I said by somebody else. Or they would say sometimes, Putin said that and it's true, but it's not important because of the EPS.
Now, so these criticisms that were levied against you, did anyone of prominence that is a climate scientist come out and say, this is a very interesting analysis of the data, these are things that I hadn't considered, Putin makes a lot of really good points?
Not in public. Not in public, in private. When I first sort of came out in that Wall Street op-ed in 2014, I had a chat afterward with the chair of a very prominent good science department at one of our best universities. I would say, oh, where? But suffice it to say, it's somebody who was firmly in the business. And he said, Steve, I agree with almost everything you said, but I don't dare say it in public. There's a whole organization called Covering Climate Now, which is a consortium of media, including the BBC and NPR, I think, and so on, who have and they have signed an agreement, or made an agreement, that they will not cover anything that diverges from the narrative.
Who establishes the narrative? What's the topic?
I think, the allegedly authoritative voices are the UN Intergovernmental Panel on Climate Change, IPCC, which issues reports, major reports every 6 or 7 years. There is the U.S. National Academies of Science. There is the UK Royal Society and the U.S. government. And, when you get into the meat of these reports, they have some problems. But by and large, they're pretty good summaries of science. But when you get to the summaries for policymakers, or you get to the media coverage, or the political discussion, that's where things get really corrupted. So it's like a long game of telephone that starts with the basic science, and the scientists doing it are by and large, good, honest, hard-working people, and you talk to them privately, and they'll admit to all the problems that they've got. But by the time it gets to the end of the public, it's, science is settled, we're headed for doom, etc., etc.
But that's always the case with something that's really controversial, right? There's always the alarmist perspective, and the people that are looking at it that have maybe a less extreme point of view are criticized because they're not taking it seriously enough. And then, which what you were saying earlier is that people are saying that they can't even say certain things because it will give ammunition to people that are real climate skeptics, right? The people that aren't paying attention to science, that have an ideology or a dogma that goes in the other direction.
There's so much analogy here with the Reformation, when the Catholic Church started to come at odds with the Protestant. Let me give you 2 examples. In one of the best recent introductions I've had, I'm a humble guy, I usually like to keep the introduction short, but this one was really interesting. I was compared to William Tyndall. Now, I didn't know who William Tyndall was, I'm not a historian, so I didn't know. William Tyndall, in the early 16th century, did one of the first translations of the Bible from the original Greek and Hebrew into English, originally Latin. So, that ordinary people read what was in the Bible. And of course, the establishment got really mad. And that was eventually the state for that. So, I sort of made these reports accessible, these parts of it, to ordinary audiences. So that's one. The other one, which is maybe more confusing, a couple of years ago, 13 senators, led by Mr. Schumer, proposed a bill that says the government may not spend any money to challenge the consensus. The Council of Trent in the early 16th century said very much the same thing about church dogma, not about spending money. You'd be in all sorts of trouble if you challenged it.
What would possibly motivate the government to come out with a statement like that they can't spend any money to challenge the consensus? And doesn't a consensus mean most? It doesn't mean all. Right. So in cases of dogmatic opinions or ideologically formulated opinions,
I'm so surprised that the government would try to suppress the scientific process like that. I think what precipitated it was I had, for a number of years, been advocating for a red team review of higher reports. And you get a bunch of credentialed people to look at the report and ask, what's wrong with this? We do that kind of thing all the time. Spacecraft, other matters of consequence when we have to make it. And I almost got to the point where we could have pulled it on the Trump administration.
now the Trump administration had some of its own problems with climate science in the wrong way, correct?
Absolutely. I felt I was, of course, a little bit concerned about going through the administration. But I had lined up the National Academies to play a good team. I had assembled pretty much a good red team, and then it was stopped at the last by a vote. So I'm really disappointed because I point out in the book a lot of problems with those reports. It says X, but in fact the truth is Y if you look at it. So we need that. It's about the integrity of the scientific institution.
So let's go back to your initial impression that the science was not settled. When you first walked away from this meeting that you were discussing, and you realized that this is either far more complex or it's influenced in a way where it's not just about the data, it's about what the narrative is. So how do you go from there before you write this book? What are your next steps?
So I started paying more attention to the disconnect between what was actually the science versus what was the much more dialogue. I think the next very important came when I was helping with a study for another government agency and had occasion to look at hurricanes. And I turned to the official U.S. government report in 2014 at the time. And you see this graph in the body of some property hurricanes going through the U.S. It almost like if I look at that graph, what a trouble. And so I did a little deeper. I looked up the reference, the site, and I read in the back of the same report, page 700 something. And it says there are no long-term trends in hurricanes, which is still largely a true statement. And I'm looking at that and I said, oh my God, that's a swindle. Part of the report that I just read, you see this graph going up and it looks like, oh, hell, it's going to break loose. And then in the back it says we don't see anything.
So what is the graph? What is the data?
So the graph is basically a graph, it's called the Power Dissipation Index, which is a graph of how many storms and how intense they are over the last 4 years.
And what is the trend?
Well, in that particular case, it was going up from 1980 up until 2010. But what they didn't show you was there was an earlier part of the graphic which it was going down. So it was really looked like it went down.
So in the beginning of the graph from 1970 to 1980, is that what you're saying it's going down?
Yep.
Do you have an image of that?
I think.
And so what they were looking at, again, we were talking about how we're measuring things on these very small increments where time for us is 100 years. It's our lifetime. So we're looking at things like as if that's a lot of time.
That's right. And there are these long-term trends that you saw in the Egyptian
Yes.
river. Can we pull up chart number 35 in the unsettled?
And we can safely assume that in those long-term trends in the Egyptian data that you're not talking about human influence because it's too long.
No, it's too much. So let's pull up chart 35. And then, so there's the original graph in the government report from 2014. And what's shown is from 1980 to 2010, and it's going up, right?
Right, but if you see from 19, it's like
Well,
1975.
so let's look at the whole record, which is the next picture. There it is. All right.
So it's real similar to the Egyptian data.
Yeah,
It's up and down.
it's up and down. Now, there's a lot of controversy still. This was 10 years ago or so. There's a lot of controversy about whether storms are getting intense. One paper says yes, another paper published in July says no, and so on. So the matter is kind of unsettled at the moment. But overall, as I can read for you, the official report, official statement from the most recent report, get it. There is low confidence in most reported long-term, multi-decadal to centennial trends in tropical cyclones, hurricanes, frequency or intensity based measurements.
Now that image, Jerry, you pull it up here, please? Yep. That image, when you see 1975, then you see 2005, it's not that much of a difference. So the peak of 1945, the peak of 1945, and then you go to 2005, you're not looking at that much of a difference. And clearly there's been a gigantic difference in the amount of human influence.
Of course. Let me show you another one, all right? Can we go to chart 3 of the other file? And this is one I think I'm going to go public pretty soon. Let's put it up. This is about Greenland. Okay? And a popular image that Greenland is melting, and it's melting faster and faster. And so on. This is the official data set for how much ice Greenland is losing every year. And it goes up right until 2021, and it starts in 1920. And what's interesting about this are several things. First of all, even though human warming influences have been growing steadily, there are a lot of ups and downs. So it says it's got to be a lot more than greenhouse gases. The second thing to notice is that in the most recent decades, at the right-hand end of the chart, Greenland is actually starting to melt less rapidly than more rapidly, even as the poles do.
And this is from 2010 to 2012.
Yeah, correct. And then if you go back to 1930, you can see it was melting just as rapidly in 1930 as it was in the last decade. And the human influences were less than a fifth of what they were.
So what are the other influences?
That's an excellent question. And the answer is this has got to do a lot with the long-term, on-a-decade cycles of ocean currents and winds. And you can find papers that say that. Research papers. But you don't hear any of that from the official papers.
So the different factors that play into what we think the different factors are that play into is greenhouse gases, warming. What are the other ones?
The others are ocean currents that have their own dynamics that are not, just getting warmer, they get colder. And the weather, if you like, because how much ice Greenland loses every year is a balance between how much snow accumulates, that's the weather, and how much flows out of the glacier.
And those are the only factors.
Basically, there's a little bit of support. But those ups and downs are really weather.
Does anything have to do with where the sun aligns with the earth,
Well,
and
yeah,
the precession of the
so-
equinox does.
Well, no, that's much too slow. I mean, over this period, year by year, it certainly has a seasonal effect. These are, annual values, so the average out the seasons. But of course, the ice grows in the winter and then it melts.
So there's all this data that shows the ups and the downs, and there's all this data that shows that sometimes they're losing ice, and sometimes they're using less ice, gaining ice. Like, how do they know what is causing this, or do they just assume that there's this series of factors?
They don't, okay? It is, it's a combination of modeling and physical principles and other data that let them try to say how much is natural variability and how much is human variability. There's no doubt that if the globe keeps warming, that warming might eventually come to dominate the icicles melting. But right now, and for the foreseeable many decades, it is these natural variabilities. And instead, in the media, all you hear is that it's been melting faster and faster over the last 2 decades.
And this media narrative, do you think this is just one of those things where people gravitate towards the most alarmist perspective, so that's the one that makes the headline? Is it because of the green energy industry?
It's all of the above, but I put a lot of it on activist reporters. So this statement that Greenland was melting just as fast in the 1930s, I made that. I got fact-checked by a reporter, John Greenberg, at PolitiFact, and he deemed the statement most infamous. And you can look at how he analyzed things, he talked to some experts. It's entirely misleading. So I got a non-expert reporter with an agenda and a platform criticizing what's actually in the data.
So the non-expert reporter with an agenda, in order for him to print something that's going to get the response that he's looking for a positive response from the people in the climate that believe these models and that think the climate is of the utmost importance.
And we're headed for catastrophe.
Yes, catastrophe. And this is the narrative that that's the only thing I've ever heard. Until I read your book, that's all I had ever heard.
Well, that's interesting. The most recent UN report, which is 3,949 pages, almost 4,000 pages, it took several hundred scientists a couple of years to write. You can search that report for the words existential threat, climate catastrophe, and so on. You find the words climate crisis once in that report. No other alarmist words. And the context for climate crisis is not a scientific finding, but a description of how the U.S. media have overhyped the situation.
Did this start with, I remember global warming in the 80s, because I'm a stand-up comic, and there was comics that would do jokes about global warming, like this is great, I can go golfing in January. They were joking around about it. But then I remember an Inconvenient Truth, and Al Gore put this documentary out when he was vice president, I believe.
No, I think
just retired.
just before or just after, I can't remember.
And when he put this documentary out, it scared a lot of people. But there was a lot of predictions in that documentary. Did any of those come true?
Apart from the fact that the globe is going to continue to warm and sea levels are going to rise, most of the predictions, that hurricanes are going to get more intense, so we're going to see more droughts and floods and so on. Almost all of the high-impact things don't show any
One of the things that you point out in your book that I found was interesting that I hadn't considered is when they're talking about the amount of damage that hurricanes do. So when they're thinking about what kind of danger there is to hurricanes, they also talk about the economic danger of these hurricanes and the damage that they do. But that damage is accentuated by the fact that the population is increasing in these areas. So naturally, when a hurricane hits, there's going to be more things there to damage.
See billions and billions of dollars just because there's more stuff there,
Right.
more people.
But that doesn't necessarily mean the energy of the hurricane is greater, or that the energy of the hurricanes over time is greater.
We can put up, if you want to see some of the hurricane statistics, but that's essentially right.
Hurricane, I'm sorry,
sorry.
But the hurricane thing is not settled. You were saying that.
But there's some indication with a paper published a year and a half ago that the strongest storms are becoming more common. But then there was another paper that said, no, it's just a proliferation. So I think that's honest.
So how do they come to these conclusions that are different if they're basing it on?
Because they're looking at two different kinds of data. The paper published in 2020 looked at satellite images of the hurricanes. We see beautiful images of the hurricanes, and you can try to infer.
Is it just me and you here, Adam?
Alarm me at 6:03 p.m.